Hello, this is day 19, Unit 3, which is Chapter 4 for us. This is rational equations again, but these will be a little bit more challenging, or just more to them. Before we had two cases, one where we had just a single variable in the denominator, and it was, something like, 5 plus 2 over a equals 7. We multiplied I just made that up, but we multiplied everything by a to get a to not be in the denominator here. Then we had the other case where we had fraction equals a fraction, like 2 over x plus 1 equals 5 over x minus 7. Again, I don't know if that works out. I just made it up, but we have a fraction equaling a fraction. And the way to do this is to cross multiply. It's the easy way out. And then the third one, which is the new one, really is kind of like number one. But we have a first step that we kind of need to do. If we have anything that's factorable in the denominator, we should factor it first. The whole point of all of this whole, this whole section on rational equations, we want to get rid of the denominator. If we're lucky, we can cross multiply, but that's only if it's just fraction alone equals fraction alone. Sometimes if the denominator is more complicated, we have to factor it. So let's factor this denominator over here. Everything else looks fine, it's not factorable. So we would get two numbers that multiply to be negative 15, but add to be 2 would be a positive 5 and a negative 3. So instead of having that trinomial, we have these two binomials multiplied together. And one way to go about this is we just look at each term by itself. And we determine, like, just whatever is on the denominator, that's what we need to get. We need to get gone. We need to eliminate that part. So in order to eliminate something on the denominator, we need to multiply that term, the whole term, by whatever the denominator is. So this first term, as I'm just looking left to right here, the first one requires an x plus 5 to be eliminated. So I'm going to multiply an x plus 5 to this whole term. Okay, and really it's an x plus 5 over 1, and when I multiply these two things, that will happen. They will cancel each other out. We did it. However, we have to multiply every single piece in this equation by the same thing we just used. So now everything is going to get multiplied by an x plus 5, or an x plus 5 over 1, if you want to think about it that way. So this is multiplied by an x plus 5 over 1, and so is this. All right, and I won't do anything yet. There's nothing, certainly in this middle term we see, there's nothing that can be done. The denominator is not going to cancel because it's a different binomial. However, the next thing I would do anyway is to look at this term. How do I get rid of its denominator? It needs to be multiplied by an x minus 3. So we multiply this term then by an x minus 3 over 1. And again, I'm just making it a fraction because we are doing fraction multiplication. And in this case, I still have yet to multiply this term by the x plus 5 over 1, but that doesn't matter. I could choose to multiply this piece first, and we would eliminate the denominator with the x minus 3. However, unfortunately, everything needs to be multiplied now by an x minus 3. So I'll go over here and make sure this one has an x minus 3 multiplied to it. I'm just putting the over 1 as a courtesy, so we're reminded that there is a denominator portion. We're canceling things out. And then this one needs to be multiplied by an x minus 3 over 1. Okay, so our first term, we used an x plus 5, got rid of, multiplied everything by an x plus 5. We looked at the next term. It had an x minus 3 in the denominator. We multiplied it by an x minus 3 to eliminate it, and then we had to multiply everything by an x minus 3. We look at this last term, and we notice, we kind of lucked out, we still have, we look at the denominator, x plus 5 and x minus 3, and we are currently multiplying this whole fraction by an x plus 5 and an x minus 3. So we don't need to multiply anything further. This and that will cancel. This and that will cancel. So that's why it's necessary to factor first, to see what this trinomial is actually made up out of, because we may get lucky and things might start canceling out. Okay, so everything that is left over that we have yet to multiply through, we should do that because we need to rewrite this equation. It's looking really messy. Everything cancels out in this first one. There is no more denominator. That was the whole point of multiplying it by an x plus 5 to get rid of it. There's a 9 on top, and multiplying by an x minus 3. I switched the order of those because usually we have the number out in front. This next one is a 3 times an x plus 5. Notice there is no denominator, no fraction, because I had gotten rid of the x minus 3. The last term, all of the denominator, both pieces, got eliminated because we multiplied this fraction by both of those pieces. So then it's just an plus an x minus 7. The rest of this now, this new equation is totally solvable. It's just, we distribute, get the x's to one side, and solve for x. So 9x minus 27, 3x plus 15 plus x minus 7. We can combine like terms. This makes 4x. 15 and 7 make an 8. And we want to get, our x is the same side and the numbers to the other. So I'll subtract a 4x. And we get a 5x. And then this 27, I want to move to the other side, so I would add a 27. And we get a 35 over there. And to solve it, we divide by 5. X is 7. Now, one thing we do want to do is just take a quick glance and make sure that if we plug in 7 into any of the denominators, that we're going to get, that we don't get a 0. Because if we look at the original equation, if you plugged in a 7 and you get a 0 in the denominator, now suddenly we don't have a valid problem. You can't divide by 0. You can't have a 0 in the denominator. It's illogical, and it cannot exist. So just quickly look. If I plug in 7 for x in the first one, we get 12. That's fine. 7 in this one, you'd get a 3, or 7 minus 3 is 4, so you're fine. In this one, 49 plus 14 minus 15. No, it's not going to be 0, so we're fine. But what happened is if you got a 0 on the denominator, by plugging in your answer, it means you have an extraneous solution. Meaning we got the solution doing it mathematically correct, but it actually cannot be. Similar to no solution. All right. Well, there's a couple ways to do this problem. Let's do it the same method. We look at the first denominator. Notice there's no variables on the bottom. That's kind of nice. The first piece of this has a denominator of 3, so certainly I would want to multiply everything by a 3. Now, the wise among us are going to see, well, shouldn't we just go for the least common multiple? Yes, but I'm going to try and be consistent with the same process. So if I multiply this by 3, certainly the 3's are gone. Now I multiply everything by a 3. Actually, what happens is now when I look at this term, I can reduce this a little bit. I have a 3 over a 6. Technically, it's a 3m over 6, but that can be reduced. 6 is really 2 times 3. And the 3's then would cancel. So really, this is an m over a 2. There's a 2 left over here now. 18 has a 3 in it. So 3 and 18 have a common factor of 3, leaving just a 6 on here if I canceled out the 3's. So 3 and the 18 can cancel a common factor of 3, leaving a 6 on the bottom. Next, again, there are faster ways of doing this, but I'm sticking with being consistent, sticking with the same process. The denominator is a 2. Multiply everything by a 2. So this would get a 2 on top, this would get a 2 on top, and this would get a 2 on top. These ones would cancel. This first piece, the 2 doesn't cancel with anything. It's just going to be out front. And then over here, the 2 and the 6 have something in common, a 2. And it would cancel, and you'd be left with a 3 on bottom. And then the last piece would be to multiply everything by, our last portion. It would be multiplied by 3. So this would cancel. I'd have a 3 over here. It's not going to cancel with anything. It's going to be there. And I have a 3 over here. And we could write all this stuff down here. So I'll do this quickly, but then I'm going to show you the faster way. 6 2m minus 3. I multiplied the 3 and the 2 that was up front. Plus 3m equals, all of this canceled, so just 5m. Now, had we had a little foresight, now that you've seen it, we saw that we had a lot. We had to multiply things over and over again, and then cancel some things just over and over again. We could notice that the least common multiple of 3, 6, and 18 is 18, meaning that a multiple of 3 is 18, a multiple of 6 is 18, and a multiple of 18 is 18. So if we use the least common multiple, meaning the smallest number that they all are a multiple of, and tried that out, look what happens. I should start out with 18. Those cancel out. 18, and this one's going to get an 18. The 18 and the 6, we would cancel, and we'd be left with a 3 on top. 18 and 3 cancel, and be left with a 6 on top. Notice that's exactly what we ended up with. And the 18's gone, we just have a 5. So if you just have numbers on the bottom, you can use the least common multiple if you have the foresight to do so. Next, to finish up the problem, we just have to, distribute, add like terms, solve for the variable. So it's 12m minus 18 plus 3m equals 5m. I'm just going to get all the m's to the right side. 12 and 3m is 15. And so minus 15m. So we get just a negative 18 equals a negative 10m. Divide. And our answer is 1.8. We could see if we plug in 1.8 to any of these m's in here, we're not going to get a 0 on the bottom. So there's no extraneous solutions. 1.8 is fine. Here's another example. I believe that's the last one. We look at it. We see we don't have fraction equal a fraction. We don't have anything to factor on the denominators. But there's two ways to do this technically here. I guess I'll show this way. I noticed that there are two denominators that are the same in this whole formula, x minus 6 and x minus 6. If I were to get them to the same side, that would just be fraction addition or subtraction, because they have the same denominator, and I could combine them. So if I subtract this 7 equals x minus 6, 7 over x minus 6 to both sides, then they have a common denominator. I could subtract this. I would just get negative 2 over x minus 6. And you see that now you have fraction equals a fraction. And I'd prefer actually this method because it's faster. You're allowed to use cross multiplication now. Alternatively, you would have had to multiply everything by an x minus 6 first, and then everything by an x plus 8. And you would have gotten just a bulkier equation to solve. Cross multiplying, you get negative 2 times x plus 8 and 3 times x minus 6. Distribute and solve. And then we want to get, x's to one side, numbers to the other, non-x's to the other. So let's see, we'll add a 2x maybe. You get a 5x, and we'll add an 18 to move these to the other side. And divide by 5. 2/5 or 0.4. And certainly when we plug these in, if you were to plug it into your original equations, we would see that we would not get any zeros on the bottom. If you did, then it would be extraneous. And so just one more word on that. If my answer was x equals 6, or if it was x equals -8, I could plug these in, one of these in, to check the answer. I'd get 7/0 plus 3/14 equals 5/0. That can't happen. It's you can't divide by 0. So this essentially that would mean, if you plugged it in, this would be an extraneous solution. So we would have two solutions, in this case. And actually, plugged in -8, we get the same thing. We'd have a 0 right there. So these would be extraneous solutions. Really, it just means that x cannot be equal to either of those. Doesn't matter. We didn't get those answers. But in case that happens, you'll want to know if they can be or can't be. All right, so the new thing today was that really the new problem is that if you have a trinomial on the denominator, you should factor it first. Good things can happen. All right, hope this works out for you. Good luck.